Howdy, howdy. Thanks for coming today to see our TTP tutorial. And what we're about is using TTPs, which are table type patterns, to provide hardware independence, to really provide the promise of SDN, which is hardware interoperability, allowing us to control it externally without knowing the details of the hardware. Well, I mean, eventually the hardware may become homogeneous, just like when you write code for servers, you don't worry about which precise version of the server, you just do the build and it'll run on the server. So that's what we want to get to in SDN space, and Open Daylight is, I would say, definitely in the lead in terms of providing that kind of hardware independent picture. Colin and I, so the presenters today, myself, Curt Beckmann from Brocade. I'm also a chair of a working group at Open Daylight. It used to be called Forwarding Abstractions, which you'll hear reference to in a little bit. And now, due to an organizational change over there, it's the Open Data Path Working Group. Colin Dixon is part of the presentation crowd. You probably have heard of Colin. And Preetam Mallappa, did I say that right? I always just call you Preetam. So, who's coming out of University of Texas, Austin, and is Dallas. My bad. You guys both know it. You know the answer. UT Dallas, and currently an intern on the TTP project at Open Daylight for the next several weeks. So we have a hands-on exercise at the end. I'm not sure if our thumb drive distribution has what we really need for all that, but it might. I guess it depends. But we also have a couple of setups here, so we can just gather together. It's not a fully polished exercise yet, but I really appreciate you guys coming here. It was good for us to have the tutorial to work toward, and we appreciate the opportunity to talk about how TTPs are going to, or ODL is going to leverage TTPs, and how you can take advantage of that and also help adoption. So moving on. Today's sequence, we actually have a survey we'd like you to take a quick look at. It's probably a 1-minute survey, 6 or 7 questions, and it'll help us understand what the community that attends Open Daylight. How familiar are you with OpenFlow, and how familiar are you with TTPs and what they're about? And it'll help us essentially market this and talk about it in the future. But that'll only take a minute. And then there's a URL for that on the next slide. We'll talk about how TTPs enable hardware independent OpenFlow. I mean, what is this TTP thing you keep talking about? And like OpenFlow, ultimately, when this stuff's adopted, there won't be that many people that know the details of OpenFlow, or probably the details of TTP. Our job is to take advantage of that technology and then hide all the hardware from everybody, right? And then how do we architect Open Daylight to give us hardware independent OpenFlow? Then we'll go and actually look at what some of these tools do and how to use TTPs with Open Daylight. And then the exercise. So I'll give you a minute to take a look at that survey. I should have had the survey up while we were doing everything else, except it was actually getting the video work, so I guess that wouldn't have worked. So I'll give you a minute to take a look at that survey. Thanks for doing that. Oh, and I forgot to add the slide at the end where we tell you all the answers to the questions, but we're happy to talk about that. Out of curiosity, what does the timer over here tell me? Okay. Yeah, it's just I thought, pretty sure I have more time than that, but okay. I'll assume everybody's got the URL that wants the URL. They'll edit this out of the video, the dead air. know I'll do that at the end. I'll do the answers at the end. And we may answer those. The answers will make more sense after we've talked about a lot of these things. So now to talk a little bit about what's driving this. How do what do TTPs bring interoperability? And OpenFlow 1.3 in OpenFlow introduced interoperability challenge. 1.0 was pretty simple, pretty interoperable. Pretty much all the features were required, so there wasn't ambiguity about is a feature present or not. There's a single flow table. Life was quite simple, although it was also very constrained. The simplicity was also a constraint. The downside was, of course, that a lot of functions were not supported, but on the upside, conformance testing was not super complicated, so they were able to develop conformance testing and conformance test a bunch of devices. 1.3 came out. It's like 3 years ago that the 1.3 spec came out. Tons of features, multiple tables, et cetera. It really turned out to be more complex than the simplistic resolve it at runtime part of OpenFlow or approach to OpenFlow would work. Was there a question? No? Okay, I thought I heard a question. So the single conformance test ended up being a problem, and they didn't have a way to generate multiple conformance tests. So basically, they've been stuck. They've made just recent progress on conformance, and part of that is through TTPs, and more will come soon. So essentially, we had this lack of what is supported, what features are supported in devices, and lack of conformance. That just stalled development on rich OpenFlow. Devices couldn't support multiple tables, and app developers didn't know what the devices were expected to support because there was no conformance. So basically, we ended up in a little bit of a stall. And of course, part of the stall was that we didn't have a de facto controller for a good part of the last several years as well. Now, obviously, we have an emerging de facto standard controller. Now, TTPs were developed to add structure, to basically reduce all that, the sort of excessive optionality that was in that space. TTPs are table type patterns. They're effectively like templates for what is being done on an OpenFlow interface. What are the tables that are going to be used? What are the matches that are going to be used on that table? And what are the actions that you can be expected to do? And this is a slide I borrowed from a previous presentation, but there's different examples, like they're a template for a specific use case. That's what a TTP is. It could be a VID mapping L2 switch or a VXLAN gateway. These would be use cases or device models or device roles that you want. So it could be made out of a bunch of different chips, either a Broadcom chip or a Marvell chip or Intel or some other chip. But if they use this same template, they can all support it the same way, and then your applications or your service layer abstractions can all write to control it through the same mechanisms. This is the point of TTPs. And essentially what they do is they capture what you have to do if you're going to control a device through OpenFlow. Even if the device does everything, you still have to figure things out. You have to figure out, okay, what are the match conditions that are going to define my flows? What are the instructions that are going to modify or manipulate those flows? And how am I going to structure this into different flow tables in OpenFlow? So it does require you write that and capture all these ideas formally in a sort of JSON format. That's what TTPs do. But it's not like you have to go through a whole other design step. You had to go through this design step anyway. So in the process of designing an OpenFlow interface, you're basically creating a TTP. Now we're just asking you to formalize it. This was the picture about how TTPs would originally be adopted. Either somebody with an application would say, oh, what I just described, I want to be able to manipulate a switch using these tables and these commands. Or it could be a device vendor says, oh, I want to expose all my functionality in my switch, and I'm going to expose it in OpenFlow terms, and so there would be a sort of a device-oriented TTP instead of an application-oriented TTP. And you create the TTP and you share it with others so that they know how to use that interface. They can use the interface to control a particular device, or they can say, well, I'll support that interface in order to support a particular use case. And every TTP has a unique name, so they're useful for interoperability and for market conversations and so on. the way things have unfolded, it doesn't exactly match this picture. We'll share a little bit more about that coming up. So it talks about, oh, sorry, let me take another step. So what do applications want from controllers? What applications want is for the controller to abstract away the hardware. You know, the idea that we'll have a services abstraction layer, that's exactly what applications need. It's not that they want to control individual devices. The northbound interface should offer services, and exactly like the SAL does. And the software-defined network movement wants a low-level southbound interface, so we want OpenFlow in order to manipulate the specifics of hardware devices, but then we want to abstract that away when we get up to the services abstraction layer. TTPs are the mechanism for doing that, and we'll share that going on. So here's a picture, a graphical picture of like a major TTP. Essentially, we produced the spec on TTPs in the ONF working group last year, and even before it came out, Broadcom had produced a TTP that looks like this. This is their version 1. They came out with a version 2 in December that is even much more complicated than this and really exposes quite a bit of the functionality that's in a lot of the Broadcom chips. I don't think it's even limited just to the Trident family line. So looking at this, you can see how thinking in terms of OpenFlow and tables and so on, this is a graphical version of a TTP, and this is kind of how you describe what you want to manipulate. But this does not, I think it's worth mentioning, it doesn't exactly represent what's in the silicon. It just represents how you control those features using OpenFlow. So it is, even when it's specific to a device, it's still an OpenFlow picture more than it's a device picture. It's kind of optimized for a device. All right, we'll look a little bit more at that as we go. Now, how do we architect Open Daylight in order to give hardware-independent OpenFlow? Now, my early picture, and those of us in the working group, the early picture was we're going to focus on use cases, not on devices. And what will happen is we'll make the devices adapt to the use cases. So the idea was that there's something in a controller, and when we were first working on this, Open Daylight didn't exist. So there would be some API mapping layer, and then we'll have different TTPs that describe a different use case. Like I mentioned, well, it'll be a VXLAN gateway, or it'll be a MPLS core router, or some kind of use case that described in OpenFlow terms how you were going to control this behavior of this device. And then the burden was on the device. If it could support multiple use cases, and many of them can, so the VXLAN gateway I mentioned and the MPLS core router, a Broadcom device can support, the same device can support both of those use cases. Maybe not every device can support multiple use cases, but many will be able to. So the idea was, well, we'll put the burden on the device to have different agents for different use cases. That turned out to be problematic for several reasons. One was, it's been very slow for people to come forward and define these use cases, these high-level use cases that they want. I think there's a number of reasons for that, but I think that's slowly changing also. And the other problem is that it's hard to develop software. Basically, devices are not great software development environments. And what we want, especially in an early stage of adoption, is something that's fairly dynamic. And what we have is, in devices, the software updates come every 9 to 12 months or something. That's just never going to work, right? We want to be able to iterate something on a rapid basis. So we moved to a new model, and this was partly driven by that Broadcom TTP that's really rich, and now we've seen some use cases that are developed above that where we have a more abstract TTP. So essentially this picture is, let's make the device support only the TTP that describes that device. So like the Broadcom device, it only has to support one really powerful TTP, and we can do the mapping between a use case TTP and a device TTP. We can do that in the controller. And in fact, we can do that with a lot of automation. So remember that TTPs are JSON. They're essentially machine readable. I say essentially because when we wrote the spec, we didn't optimize it for machines. And so there's a couple of cases where we could do a little bit better job, and we will. Colin's done a bunch of work. You know, I've been cheerleading in the background, but basically Colin did a bunch of Yang work so that Open Daylight can now absorb a TTP dynamically and present APIs that make that TTP available. We don't have it yet. We don't have this two-stage TTP model yet. That's going to come in Beryllium. and we'll have the ability to map between a use case and a device TTP using automation combined with the human during development phase. But essentially, this model is much more straightforward, much easier for the device vendors to support. They just optimize for their device, and it also will expose device functionalities in ways that developers can understand. You can go look at different TTPs and say, okay, I can create a use case TTP, I can create that MPLS core router TTP, and it'll work on various devices. I can tell because I can see their TTPs. So all this stuff is very much within shooting range for Beryllium, and we already have a great device TTP from Broadcom, as I already showed a picture, well, a simplistic picture of version 1. Version 2 is much more powerful, and we have the JSON for that TTP already, and we've imported it into multiple times into Open Daylight. And we also have now use case TTPs are starting to be developed by teams at the ONF and so on. So we're now now we just have to, we do have work to do up in the fully abstracted northbound interface, basically the SAL. So actually tremendous progress on a number of fronts there. And the other thing that's we're made progress on is tools, which we'll talk about in a little bit. So current support for TTPs in ODL, we are able to import the JSON formatted TTP into the controller via this Yang schema that Colin has developed. And we actually show a video about that in a few minutes. That was working a little bit ago, so it's not a super recent video, but we decided to not reinvent the wheel since we had a good video of it. We also now have the ability to, so you don't have to do all these manipulations using the full controller. There's now a parser package, which is a much smaller command line utility, but it uses the same source code as the controller. It's just much more lightweight, and it starts in a second or two instead of 20 or 30 seconds or whatever. So you can import the TTPs again using the same Yang schema. We can manipulate those TTPs. We have the number of command line options. You can validate and say, okay, this is good for when you're creating TTPs to do a validate. We can generate a graphic, which we'll show you, that shows you how the tables are linked together. And that's more also of a human validation. In the one case, you say, well, that's perfectly valid JSON, but then it turns out it was perfectly valid JSON and perfectly valid TTP language, but it didn't do what I wanted. So that's the utility of the dot file, is you can look at the way the tables connect and you can say, yeah, that's the thing I was aiming for. And so there's other similar kind of validations. One is called flow paths. We probably won't get into that today, but it allows to look at the ways, the full complexity of a path through all these tables. And the value of that full complexity is that you can now begin to compare different TTPs. So going back to that, this picture here where we've got use case TTPs and device TTPs, we can now compare those programmatically and find there are basically flow mods in the use case, and we're saying, okay, what is the device TTP that can support this flow mod that's defined in the use case TTP, and essentially we'll provide that mapping probably under human control initially, but then we'll go through a process of enhancing TTPs, the TTP spec and the TTPs themselves until we get to a point, probably in another iteration, where that is all done automatically, and the human is not even required except for maybe test definition or something. But pretty soon we'll be able to do that abstract to functional mapping in an automated pass. So this parser tool adds all these different utilities. And now we'll take a look at that video. I give Colin the opportunity to stand up and say all the things that I neglected to say before. Okay.
So is this live? Okay, perfect. So this really is just going to show that we have a Yang schema that basically describes the format in the JSON of an ONF TTP, and this was useful predominantly. really, what we've done so far is scratch an itch. We created this thing called TTPs, and there is this English-written spec that solved the problem we sort of knew existed, but didn't really provide any tooling in order to figure out had you written a TTP correctly, could you get it parsed into a programmatic thing you could get at. And so really what we've done is we've iteratively written tools that have helped us figure out, is this TTP actually syntactically correct? What is it semantically correct? Can we look at it? And so this is sort of the first test, was basically, can we get a Yang schema that'll actually do this and read it in and out? And this shows yes, we can more or less get exactly where we want to be in terms of that. And then that sort of formed the basis of the rest of the tools we're making. And the next step is what we really want to do is make this useful to app writers and developers. But it's been a personal itch we've been scratching as opposed to a full-time development effort. And so we're making slow progress. But one of the things I'd love to see is if people here are interested, please come help out. We can always have more tasks. But with that, I'll just kick this off, and hopefully the audio will work.
Yeah, do we have to take it out of presentation mode maybe, or? Oh, it shouldn't be doing that. It should be going to.
Will that actually work? Let me see.
I didn't try that. I tried it in Chrome, and I think I still have it up in Chrome. So
okay, you can just fire it up, whatever makes sense. Sorry, I tried to be fancy and download the video as opposed to playing it through YouTube.
Yeah, and I downloaded it. Nope, not there.
I can.
Plus, it's probably not going to be. Yeah, we can.
Well, you can drag it to the other screen, can't you?
Oh, probably.
Where's that? There we go.
Oh well, I have that URL that was on the.
And so you can find this in the same way that I'm about to find it, where I uploaded it and then forgot the URL. And hopefully this will play with audio.
Hi, my name is Colin Dixon, and today I'm going to talk to you a little bit about table type patterns in Open Daylight.
There we go.
So table type patterns is a specification released by the Forwarding Abstractions Working Group, the FAWG or FOG, of the Open Networking Foundation, and they basically describe a way to have a named subset of the functionality possible in OpenFlow 1.3 and later versions. And they do this by basically describing this set of tables, the kinds of flows you can have those tables, how those tables can interact, the set of groups, the set of meters, etc. And they do that in a format which is in JSON. And in order to implement this in Open Daylight, I have created a Yang schema which describes the valid JSON which you can have as a table type pattern. And you can go and find this online, the table type patterns project repo inside of Open Daylight. If you just search for Open Daylight table type patterns, you'll be able to find it, so you don't have to bother looking at this. But essentially what this describes is a set of valid JSON along with some notes and documentation about how it works. And so a given table type pattern looks something like this. And this is a verbatim table type pattern which I have gotten from the Forwarding Abstractions Working Group. This one describes the Broadcom OpenFlow data plane abstraction stuff, which was released earlier this year at the Open Networking Summit, and you can go find talks online there about that if you're interested. Anyway, this describes sort of some metadata about it, some features, list of the table names to number mappings, identifiers used, the tables used, etc. And so you don't really need to worry too much about the details here, but basically this is a piece of JSON that describes the functionality available on a switch that would implement the Broadcom's OpenFlow data plane abstraction. Now, the Yang in Open Daylight doesn't quite match the Open Networking Foundation spec for TTPs exactly, and one of the few small differences is that in the ONF spec, documentation can either be a list of strings, like here, or like here, but it can also be a bare string like here. And in the Open Daylight version, we only support lists. So I'm just going to run this simple irregular expression which finds all docs that are not lists and replaces them with lists. And there are 49 of those, and that's fixed. A second thing which I know that the Yang doesn't support well is that table maps in the Open Daylight Yang look something like this, where there's a name and a number in a JavaScript object as a list instead of a single object that maps the names to the numbers. It's not quite as pretty, but it works. And so I'm just going to replace that. And with those two modifications, I'm going to show you how it is that we can start to get this into Open Daylight. And so the first thing I'm going to do is just show you that we have a running Open Daylight controller, and is actually dynamically updating its REST interfaces based on the model, Yang models loaded. And you can see there's an ONF-TTP model. And this ONF-TTP model has a series of APIs around pushing table type patterns in and out. One of them is that it has a global list of all the table type patterns it knows about, which is what this get, put, delete, and post are about. And you can essentially do a get, put, post, or delete in order to add this. The rest of this is about sort of the sub parts that can happen. In addition to having a global registry, the inventory, which is how you program flows in Open Daylight, has an active TTP for each node, which means that a node is a switch. So any given switch can have an active TTP. They can also have a list of supported TTPs. And so this is sort of just where the data gets merged into Open Daylight. So let's for a second go look at the actual REST APIs. So the first thing which I'm going to do is I'm just going to post an empty TTP to the APIs. Technically speaking, an empty TTP, which is this, isn't legal, but we haven't made things mandatory in the Yang model yet. That'll be coming in a little bit as we enhance things. But you can see that, in fact, if we go back and get this, in fact, you get it back. So let's go try putting this TTP into the TTP that we had into Open Daylight. So let's go grab it. We're going to copy the whole thing. And we're going to highlight this empty TTP and replace it with this TTP, and we're going to click send. And now you can see we get an error, and it says the schema node action list was not found in the module. And this is actually because this TTP, which I got from the Open Networking Foundation, has a bug where they used action list instead of action set to describe some of the fields, where action set is the one that is actually in the spec. So we're going to replace all of those. There are 11 of them. And now we're going to copy this, and we're going to paste it in again, and see if we can't find any other bugs. And so, in fact, we now see that the schema node group was not found.
So one of the things that we've done is we've developed tooling around this. Rather than having to paste things into REST APIs and get security errors, we have a parser which you can run from the CLI. It pulls in files. This was sort of the first demo that we did. And so really debugging this kind of thing, this is the first time we were able to debug it, and that's why this ended up in the video.
So I'm going to go look for group here, and it turns out this was another bug. So if I look for group : I'm going to find this, and this was actually supposed to be group ID. And I just want to make a quick note here that this actually ability to catch bugs like this action list versus action set and group versus group ID is exactly the kind of things which we're really hoping this TTP specification in Open Daylight can help, because it gives us an automated tool chain which you can go play with, use to evaluate your TTPs and figure out if they're complying. And so we're hoping to turn this into a little bit easier to use tools in the next couple of weeks, and we should be able to give you an announcement about something like that. So it turns out that I've already gone through and fixed one last thing in the TTP, and I can show you that here. So if I do an ls on parser, OF-DPA, D4 star, you can see there are 4 things here. One of them is the original TTP, the .ttp file I got from the forwarding abstractions working group. The second one is a fixed TTP, where all I've done is change the 2 bugs we talked about and change the docs to always being lists. And this last one is the ODL TTP, which is the version that ODL will actually take in. And there's another one which is ODL and XML, and I'll talk about that in a second. So if I do a diff between the parser and the version that is fixed but is still valid Open Networking Foundation TTP spec, which is say that even though I've modified a little bit, it is still completely valid TTP according to the ONF, and the parser of TTP, the .d4.odl TTP, this one is the one that I've made that will actually important to Open Daylight and is no longer quite a valid ONF spec. And let's pipe those differences to less. You can see there's only really 2 sections that differ. The first one is this table map, which you already saw. And the second part is a part around using what the Open Networking Foundation's TTP spec calls meta keywords. And exactly one is one meta keyword, and that says that you should replace this block here with exactly one option of these group IDs. And I changed this to something which is semantically equivalent, which is just an expanded list of the 6 different complete actions, where you specify the action as group and the group ID is here. So I said I would talk a little bit about the XML as well. Basically, the REST APIs allow you to, in addition to getting JSON out when you do a GET, you can get XML out. And so I've actually saved off the XML the last time I did that, and you can get this parser OF-DPA for ODL XML, and we're just going to less this, and you can see that this is in fact the same contents just represented as an XML document. So this is actually a pretty cool way where you can go back and forth between JSON and XML, because essentially Yang modeling and the tool chains that we have are the gift that keeps on giving, and effectively this gets us XML for free. The key point that I want you to take away here, though, is that this fixed TTP is essentially only just a straight up regular ONF spec TTP that I got from the 40 abstractions working group, where I fixed the 2 bugs that I found, which the tools enabled me to find, and then changed the docs. That way the docs used only lists of strings instead of bare strings, which is a trivial regular expression fix. And the difference between that and the version which actually imports into ODL here is very, very small. And I have this as the ODL TTP. And if I actually go grab this and paste this into Open Daylight, you are able to see that it gets posted. I can go back to get all TTPs, and I can get this. And so this is actually a relatively complicated TTP, and probably a good example of, as complicated as things get in terms of how you can do stuff. Yet we're able to read it in, parse it, and load it up inside of Open Daylight. It also would be available to Java APIs, which are native, which would give you things like the ability to say, get the table type pattern, and then look at the NDM metadata. And we're looking to make new APIs that will make this more useful in the future. This includes APIs that would let you actually, place a flow mod in the right table based on the TTP, as well as to request certain TTPs from certain switches, so that way you can negotiate them if they're available. If you're interested in more things, as always, come to the Forwarding Abstractions group meetings, or get involved in the Open Daylight TTPs project, and you can send a mail or find the project by searching for Open Daylight TTPs on the web. Thanks.
And then if I press escape and then minimize this, you should be back. There you go.
Thank you. Thanks, Colin. It was interesting how you anticipated yourself, sort of, in reverse. Anticipated what you had said some time ago. I got all these files I've got flying around here. Yeah, what have I done? Well, I can just move on. So we've got a bunch of other useful tools as well, and actually part of what today's about is generating or manipulating JSON utilities, TTPs. And TTPs conceptually, this is something that we think about if we think about OpenFlow and we're manipulating OpenFlow. But JSON, we don't think in JSON that much, most of us. So how do you get this concept of a TTP captured into JSON? And you saw the JSON version of the files, and they're just not really that natural for us humans. As it turns out, Broadcom developed both of their TTPs, the early one, which seemed complex at the time, and then the one that they brought out last December, which is like another order of magnitude in terms of complexity. And all that was developed, they used Excel as the basis for constructing it. So it's very tabular. Of course, you can create drop-down lists and so on. Then they went through a process that converted it into JSON. Now, we thought at first that they were going to convert it into comma-separated values, CSV files, and then just programmatically convert that into JSON, and we were going to just happily take their utilities, but they didn't do it that way. They did it some other way, and they basically said, no, please, we'd rather not give that out because they're a support nightmare. So I said, well, I'm going to be inspired by that and create my own Excel to JSON process, which we'll show in a minute, and just a second. There we go. In fact, I can haul this up now and put that on the screen. Where is it? Yeah, there we are. So this is my Excel spreadsheet that converts into a JSON file. So what I've done is I've created these green fields are fields that need to be filled in by the user, and the rest of it is just kind of boilerplate that is part of making the JSON. This is not nearly as complicated I mean, it's somewhat complicated, but it's a little bit more guided than just typing in JSON. So you click here, you have a choice of fields to enter, you have a choice of types, match types. There's a choice of match fields. You know, just the same old OpenFlow stuff. You got the 40 different kinds of, this is in OpenFlow 1.3, so you've got a bunch of different types of matches that you can select and so on. And then at the end, when you've done all this editing, you can save this to a CSV file, and I did that with a macro. It doesn't really require a macro, but it turns out there are some annoying side effects if you use either export or save as, and the macro avoids those. On the downside, the macro that works perfectly well in Windows, when I tried it in Mac, didn't work the same way and generated an error, so it's not a highly portable utility, unfortunately. But it has been fairly, I can see why Broadcom used it. It is useful using a spreadsheet model. Now, as it happens, there's other spreadsheets. We may look at using something more portable like LibreOffice or Google Sheets or something. But anyway, that's what today's exercise is based on, is using Microsoft. And it spits out that comma-separated values. And then I have as it happened, I tried to use sed, but SourceForge was acting weird that day, so I used Vim instead, running a script that I didn't have problems with. So a simple script takes the CSV file that is generated by Excel and zip-zop produces oh, I forgot to show something, produces the JSON, the fully legal JSON. It just takes a little while to create the Excel file. Now, one of the things Colin pointed out in the video was that this table map that shows name, essentially associates names with table numbers. The ONF version just has the name and it has the number, but it turns out that's difficult to model in Yang, and it's also difficult to represent in Excel, XML. So a better way to do it, and probably the way we'll do it in the next version of TTPs coming out of our working group, we'll basically say, well, we don't want to make life difficult, so we're going to update the spec so that this model of name and number, or something very similar to this, is the preferred way. So that's actually the way this Excel spreadsheet works. And it's much easier to go from this format to strip out name and number than to go the other way. So anytime I had a choice of that, which way to implement something. So for example, the way things are done in the ONF, they optimized for humans, and they left off these prefixes that are always the same. Instead, it just allows you to put an import. In this case, I put in the prefix because it's easy to strip the prefix out, and in fact, that's what my Vim script does. And this way, we can make we can run a different script, and it'll generate an ONF version, or it'll generate an Open Daylight version. I think actually the Open Daylight version doesn't require the prefix either, but it requires a lot of extra work. And if the prefix was there, we could leverage some awareness that Open Daylight already has built into it, and it would take less work. So this is our format. Essentially, this Excel file that represents a TTP, it actually represents a pseudo-legitimate TTP that has 5 flow tables in it. And the exercise for today is to actually alter this 5-table TTP to be a slightly different TTP. So hopefully, if I don't take too long, we'll actually be able to see that. There's some other nice tools. So I mentioned that we are looking at potentially implementing the same idea using a more platform-independent option. There's also something if you want to check your JSON, which we're often wanting to validate something quickly. There's a JSON editor online, and then it's an interesting name because there's also a Chrome plugin option, which it's still called JSON Editor Online, but it works offline. And it makes for very quick testing. And it sort of points out, what's the character that's not expected or misplaced and so on. Gives you enough feedback that you can fix your Excel file or your script. And it's pretty good for viewing as well. If you just want to scroll through, it's got nice coloring and so on. And then another tool that I haven't played with very much, but it's much richer and it's much better for editing JSON, for copy and pasting and inserting and so on. It would be very useful for manipulating a TTP that you already have. Say if you want to say, well, I want to make a subset of Broadcom's TTP, I'll go take the Broadcom TTP and it. I haven't tried the Broadcom TTP. It may not, because it's so large, it's like 23,000 lines. I don't know if it would work in this utility, but this looks like a very useful utility as well. Oops. Okay, so support that's coming soon into Open Daylight, as Colin mentioned, or Colin's video mentioned, or both, is that we want to be able to compare two TTPs. So I mentioned the application level and the device level TTPs. We need to be able to compare them and find out which functions in the use case are implemented by what tables in the device. And in some cases, something that's one table in the use case may be done in two tables in the device. But our comparison function should be able to match that in any case. And it could be that you may have multiple choices, and it's going to be up to the human probably in the near term to figure out which of the two choices is the one that really makes sense. Or maybe you have to send it both ways because there's some other variable going on. And we also need to work on, and this is something that we're just now looking into, is how do we provide service layer abstractions that sit on top of these app-oriented TTPs. And I think that's a function that's just part of maturing Open Daylight in any case. Other progress is, as I mentioned, there's a 1.1 version of the spec for TTPs that we're moving forward on. The original version of 1.0 was meant to be like, eventually we're going to get to machine readability, but gee, let's focus on the humans for now. And it turns out machines were using TTPs before most humans, so I'm happy we got that one wrong. And the good news is we were close enough that we could actually demonstrate machine usability, but now we're going to go make 1.1 more optimized toward basically tools. And then you can use tools to make the humans happy, as we're trying to do now. But I'm sure there'll be much better tools over time. What do we need? We actually need more TTPs. TTPs are, they're not something developed by standards bodies only. These are templates. They're meant to be produced by the people who are, basically by the larger community. We need app-level TTPs. Some of that's coming. There was an Atrium project out of the ONF, and they developed something they didn't call it a TTP at the high level, but it's basically a TTP in our view, and it's very easy for us to make a TTP that represents the same thing that they're representing. And then we'll also get more device level TTPs. We've got the Broadcom one, so we're not held up. We've got a great TTP from Broadcom. And I think as we move forward in ODL, supporting the, making the Broadcom TTP more valued, then I think other vendors, other chip vendors, and other device vendors will, which may be FPGA based or whatever, it doesn't have to just be chips, they'll come forward with more TTPs at the device level. Okay, so for the hands-on exercise, I don't know if what we provided, we gave a download of, on the thumb drive, did you guys get a thumb drive? We uploaded stuff that they said would be distributed as a thumb drive.
There's a thumb drive here which has it on it.
Yeah, but does everybody have one in their packet or whatever?
No.
I don't think.
I think there's one per room that it was passed around. Do you have the things would you even have on your computer? Could you put that on this and I can hand it around?
I have a bunch of things on there. The several things that I emailed you? Yeah, put those on there. Oh, not the zip. the 7 or 9 files I just sent to you. So while they're putting that on the drive, I mean, we have a couple of stations here that we can, you can just gather around, or potentially you can get the thumb drive and do it yourself. So what we want to do with this exercise is just take that Excel file that we had and add another flow mod type, essentially to extend the TTP to represent another kind of function that was not represented originally, and then to save that to the comma separated value and convert it to JSON through the Vim script. Now, some of the things we didn't, like the utilities, I didn't put Vim on the thumb drive, but we can download that. Preetam downloaded it and installed it, and I don't know how long it took you. It seemed like about 15 seconds or something from SourceForge. And then we can validate that using the JSON Online, which you can do either on the web, or you can install the Chrome utility if you do that in advance. And the thing that the functionality that I propose that we add, and this is it's sort of a pseudo useful TTP to begin with, and then I say, oh gee, I want to be able to so typically a switch will route only if the MAC address actually matches the MAC address of the router, right? That's sort of a reasonable thing to do. And if it doesn't match the MAC address of the router, or the router MAC, then we don't want to route it because it's not for us. Instead, we'll switch it, right? So typically, like a Broadcom device can either switch or route, and the choice is made based on whether the MAC address matches the router MAC. On the other hand, I've heard there's cases where somebody says, well, based on some other special use case, I want to, if it matches my some ACL tuple, then I want to route it. So some special case. So that's what I'm adding is if it matches as a 5 tuple, then send it to the table that does routing and bypass the router MAC check. And so we can do that in this Excel spreadsheet by just changing, it's about 10 lines that need to get changed, and there's a slide that tells you which is 10 lines. Now this is basically just an exercise to build a little bit of familiarity with kind of what it's like to manipulate a switch with OpenFlow and how you think that through and capture that in a TTP format. So the process for doing this is we modify the Excel, and I'll pull that up and do that live. Well, I'm not sure that's a good idea, but I'll do like one step of it to just show what we're doing there. And then save it to the CSV, convert it to JSON using the script, and validate it with a JSON editor. Then we'll, in my cases, unfortunately, we're not able to do this all on a single platform. I tried to do the Excel stuff on Mac. That didn't quite work, and I haven't got the parser running on Windows yet. So I actually move between these different functions. I think we've gone quite a long way. Even if we just do the first bullet, you've basically validated that you got valid JSON out. And often that's correct, but it turns out it took me a long time to get valid JSON out of my little Excel script pass, and then it took a few more iterations for the valid JSON to represent the TTP I wanted. I had to go back and forth to my Mac a few times. But anyway, then we check it into the Mac, and then it always does a validate anytime you absorb it into the parser function, but generate a dot file. I'll show you the output of the dot file in a minute. And in theory, we could go through the process of actually converting the dot file into a graphic, but that's a little bit of extra work, and it's not necessarily that much fun. So here's a picture of actually what the dot file produces if you run it through another utility called GraphViz or Nito, and it shows the tables. It's sort of curious how it decides where the first table is. But in this case, the first table is at the bottom. LLDP is where it checks for. In this case, my flow table is saying, are some of these for link layer discovery protocols? Well, I'll send those to the controller. Then it goes to my ACL table. And if it passes the ACLs, then it checks for router MACs, and then it either switches or it routes. And the thing I was proposing is that I want to be able to have a path that goes from the ACL table directly to the L3 routing table. So that's what we're going to be adding today. And these are the mods that we're going to make. I can leave this on the screen. in case you get the Excel file and you want to make the edits yourself, and just pulling that up now to take another look at it. So for example, on the first row, the path name, I've got a little note there to change the path name. I won't do this right now, but I did go through that step. And so later I diffed the files, the CSV files, to figure out what are the lines I changed. These are the lines I changed. Then we go down to, what did I do? I hit the wrong key, sorry. So down here at the very bottom, well, bottom of the screen, but not the bottom of the file, I had reserved a spare flow mod type. Every flow mod type takes, I don't know, 40 lines or something in the Excel sheet, and I'd left a blank flow mod type so that I could modify that and say, okay, well, we need to change the name of the flow mod type and say ACL-based routing or something. And then we go to 166, which is just right here, actually, down into this other green territory, and we enable these different match fields. So if it's blank, they're not enabled. I should probably make this so it's a little bit better hint what happens if you click there. But we turn on these different match fields. And I won't go through the whole modification process, but essentially you can see, conceptually what's going on there. Okay, I want to check for VLAN ID, and then I want to check for Ethernet dest. And this is the kind of functionality, or the kind of step-by-step process that spells out how an OpenFlow interface is being used to control a device. It's very useful to the device to know in advance what this looks like, because as you can see with the complexity of OpenFlow, I mean, if you're a device-level coder like I was at one time, I remember thinking, there's no way in the world I'll be able to process all the possible OpenFlow commands that are coming my way. But once you structure it and you provide basically a framework for what OpenFlow commands are coming, now it's much more manageable. And it's, in fact, as Broadcom did, if they know enough rules, I mean, if they can provide the structure themselves, they can define huge numbers of rules that allow them to manipulate all the power, or almost all the power, of the Trident chipset, that was just completely outside the range of possibilities without a TTP. They were just never going to be able to expose all their silicon capability. So TTPs have already been sort of useful in that way, and we're going to move forward and get them more useful. So I think at this point we've covered enough. Let's see what's on the next slide. I'll go back to the presentation, and I don't think there's anything too exciting on the next slide. Oh, there's how to use the Vim script. It's probably better if we just talk through that. You just open VI, edit the CSV in VI, and then source the script that's, I think, being passed around here. It strips out the commas and strips out the various other unnecessary stuff. This is some more information on how you can get involved. You can reach out to Colin or I, or to find us on the TTP project at Open Daylight or at the ONF. Of course, Open Daylight's more open than the ONF, so it's easier to get involved in that. But if you're an ONF member, we'd love to have you participating on that side too. Okay, so back to this. And with that, the presentation is done, and we're going to shift over to the hands-on exercise, and probably gather around and form teams if you want, or if you want to do it on your own, raise a hand if you need help, and probably one of the three of us can help. And we've all been through this a little bit, but it's also a little bit of a work in progress. So thanks for going through it again. Is there anything I left out? Anything you want to say, Colin? All right, thanks. And I guess go ahead and turn me off, and we'll get our hands dirty on some flow mods. So after brainstorming a little bit, we've decided to just go. I'm going to walk through that exercise with the tutorial TTP. Whoops.
And we'll post the files and some
Yeah.
instructions to the wiki after this.
Absolutely. We'll make this much more recipe-driven and post it in the next few days. If you want like an email notification, can we get a list going? Just
I should have posted. If you search for OpenDLA TTPs, they get the wiki page. I'll just post information there. You can make it.
okay. Yeah. So there's a project main page. Is that the one you mean?
Yeah.
Yeah. So we were going to do that anyway, independent of even if this had gone really well. We want to enable people who are not attending today to do it, but you'll have the advantage of having seen this before. Okay, so I'll make these edits that are shown up here, and then I'll go through the process of exporting it to CSV and converting it. It's all pretty straightforward, but worth walking through it. So there I got the Ethernet dest, Ethernet source, IP, and of course the hard part of this is, like I was saying before, is figuring out, not so much figuring out the how to represent it in JSON. The actual hard part is essentially designing your network architecture. So what is it do you want to match on, and so on. And once you know what you want to match on, representing it in a TTP is not especially hard. No, I can even take advantage of Excel little tricks like this and copy that entry. So I want match type and all those. And here I'll have match type be all or exact. I think that's what I wanted. Let me just take a look here. All or exact, and then prefix, yeah. So all or exact. And prefix. So, I mean, I'm on the ONF working group, and even I can't just sit down and type out this JSON stuff, even as familiar as I am with it. So it's actually quite helpful to have this Excel spreadsheet here. You know, I can say, okay, what are the different options? I forget. Or not just what are the options, but how do you spell them? You know, how is that abbreviated? Does this one have an underscore? And those kind of things. So it's really much simplified to have drop lists. Okay, so that was all of them. Let's see, I came up with ACL-based routing. I'll go ahead and change the file name, which I didn't do earlier. Tutorial mod, which is not what I called it before. But since we're going through this live, so what did I say? There's row 176 also needs a change. So we'll say A176. And I have to change, I have to turn on the go-to instruction is not enabled in this case. I have a sort of a no-op. This spare flow mod type that I had left in the Excel file, it was a do nothing, so it had no instructions turned on. So I'll turn on this instruction. It's go to table, and then I have to set the correct table name. Seems easier to do up here. Okay, and I think I've done everything. And I'll save the sheet. Boop. And that's it. It saved it. Now I'll go find another. It saved it to tutorial mod CSV. I'll open that edit with Vim. And here's what it spit out in Vim. Let's see, can I change the font size to something you can see? That's good. Yeah, is it important? All right, I'll skip that part. If it was easy, we'd do it. But we're not really going to look at that. But the point is that there's commas all through there and all sorts of things. I run source, my TTP v1 strip.vim, and it does a bunch of changes. In fact, it strips off those prefixes, like I mentioned, and so on. And when you're done, boom, you get basically JSON. I say basically, I mean, it is JSON. So I'll write that out to tutorial mod.ttp1.json. All right, and now, where's my file here? Actually, I can hide that. Come back and get my browser window. So as I already have my JSON editor, and actually this is not my online, so it's the Chrome extension. So Chrome extension is pretty easy. I can say open from disk, choose the file, this file, and open it. And all right, there's my, it's valid JSON. It was pretty uneventful. It's much more interesting when it's invalid JSON and it gives you errors, but this is the JSON we just entered. I think if I go down to line 1, oh no, this is much different line numbers because it strips out all the blank lines. But it's in the ADL or ACL. ACL-based routing, yep. So this is the thing that I just entered, and it has the checks and a go-to L3 table. So this is the stuff that we just entered, and it's now in JSON form. I haven't done what Colin was just telling me. Gee, you should have downloaded and run the Java on your Windows box. I've never actually tried that, but it should. Huh? Tell you the file? You want me to email you that? Okay. Anyway, any questions? That's largely the exercise. Unless does anybody trying to run the parser or trying to run the controller?
Does anybody have any questions of any kind?
Yeah.
Let us go to the bar and get a drink.
Yeah, if we're between you and the bar, forget about it.
Can you do my
Yeah, this one. I love that question. That's an excellent question. All right, apologize. I have to take away the presentation laptop here. So to go pick up my son. Way to generate multiple conformance tests. So basically they've been stuck. They've made just recent progress on conformance, and part of that is through TTPs, and more will come soon. So essentially we had this lack of what is supported, what features are supported in devices, and lack of conformance. That just stalled development on rich OpenFlow. Devices couldn't support multiple tables, and app developers didn't know what the devices were expected to support because there was no conformance. So basically we ended up in a little bit of a stall. And of course part of the stall was that we didn't have a de facto controller for a good part of the last several years as well. Now obviously we have an emerging de facto standard controller. Now TTPs were developed to add structure, to basically reduce all that, the sort of excessive optionality that was in that space. TTPs are table type patterns. They're effectively like templates for what is being done on an OpenFlow interface. What are the tables that are going to be used? What are the matches that are going to be used on that table? And what are the actions that you can be expected to do? And this is a slide I borrowed from a previous presentation, but there's different examples, like they're a template for a specific use case. That's what a TTP is. It could be a vid mapping L2 switch or a VXLAN gateway. These would be use cases or device models or device roles that you want. So it could be made out of a bunch of different chips, either a Broadcom chip or a Marvell chip or Intel or some other. Howdy, howdy. Thanks for coming today to see our TTP tutorial. And what we're about is using TTPs, which are table type patterns, to provide hardware independence, to really provide the promise of SDN, which is hardware interoperability, allowing us to control it externally without knowing the details of the hardware. Well, I mean, eventually the hardware may become homogeneous, just like when you write code for servers, you don't worry about which precise version of the server, you just do the build and it'll run on the server. So that's what we want to get to in SDN space, and Open Daylight is, I would say, definitely in the lead in terms of providing that kind of hardware independent picture. Colin and I, so the presenters today, myself, Curt Beckmann from Brocade. I'm also a chair of a working group at Open Daylight. It used to be called Forwarding Abstractions, which you'll hear reference to in a little bit, and now due to an organizational change over there, is the Open Data Path Working Group. Colin Dixon is part of the presentation crowd. You probably have heard of Colin. And Preetam Mallappa, did I say that right? I always just call you Preetam. So, who's coming out of University of Texas, Austin, and is Dallas. My bad. You guys both know it. You know the answer. UT Dallas, and currently an intern on the TTP project at Open Daylight for the next several weeks. So to give us hardware independent OpenFlow. Then we'll go and actually look at what some of these tools do and how to use TTPs with Open Daylight. And then the exercise. So I'll give you a minute to take a look at that survey. I should have had the survey up while we were doing everything else, except it was actually getting the video work. So I guess that wouldn't have worked. So I'll give you a minute to take a look at that survey. Thanks for doing that. Oh, and I forgot to add the slide at the end where we tell you all the answers to the questions. But we're happy to talk about that. Out of curiosity, what does the timer over here tell me? Okay. Yeah, it's just I thought, pretty sure I have more time than that, but okay. I'll assume everybody's got the URL that wants the URL. They'll edit this out of the video, the dead air. I know I'll do that at the end. I'll do the answers at the end. And we may answer those. The answers will make more sense after we've talked about a lot of these things. So now to talk a little bit about what's driving this. How do what do TTPs bring interoperability? And OpenFlow 1.3 in OpenFlow introduced interoperability challenge. 1.0 was pretty simple, pretty interoperable. Pretty much all the features were required, so there wasn't ambiguity about is a feature present or not. There's a single flow table. Life was quite simple, although it was also very constrained. The simplicity was also a constraint. The downside was, of course, that a lot of functions were not supported, but on the upside, conformance testing was not super complicated, so they were able to develop conformance testing and conformance test a bunch of devices. 1.3 came out. It's like 3 years ago that the 1.3 spec came out. Tons of features, multiple tables, et cetera. It really turned out to be more complex than the simplistic resolve it at runtime part of OpenFlow or approach to OpenFlow would work. Was there a question? No? Okay, I thought I heard a question. So the single conformance test ended up being a problem, and they didn't have we have a hands-on exercise at the end. I'm not sure if our thumb drive distribution has what we really need for all that, but it might. I guess it depends. But we also have a couple of setups here, so we can just gather together. It's not a fully polished exercise yet, but I really appreciate you guys coming here. It was good for us to have the tutorial to work toward, and we appreciate the opportunity to talk about how TTPs are going to, or ODL is going to leverage TTPs, and how you can take advantage of that and also help adoption. So moving on. Today's sequence, we actually have a survey we'd like you to take a quick look at. It's probably a 1-minute survey, 6 or 7 questions, and it'll help us understand what the community that attends Open Daylight. How familiar are you with OpenFlow, and how familiar are you with TTPs and what they're about? And it'll help us essentially market this and talk about it in the future. But that'll only take a minute. And then there's a URL for that on the next slide. How TTPs, we'll talk about how TTPs enable hardware-independent OpenFlow. I mean, what is this TTP thing you keep talking about? And like OpenFlow, ultimately, when this stuff's adopted, there won't be that many people that know the details of OpenFlow or probably the details of TTP. Our job is to take advantage of that technology and then hide all the hardware from everybody, right? And then how do we architect Open Daylight?